And the last question we looked at was question 9 from November 2009, or the last previous exam question anyway. Find the angle AOB. So we know OA and we know OB. So you can do the dot product again, you can find the lengths between them, and we've already kind of done that question. And you can go find the answer from November 2009. And I think I can actually show you that answer in a second. So let's go to this one instead. Part 2, find a vector which is in the same direction as AC, but has magnitude 3. So on the other questions, it mainly talked about unit vectors. So that was one of the reasons why I wanted to pick this question out here. So A to C, I know involves these two things here. Here's my vector A, and here's my vector C. So I got to do C take away A. So -2 take away 2 is -4. 5 take away 3 is 2. And -2 take away -6 is 4. If I work out the lengths from these, this squared is 16, this squared is 4, this squared is 16. When I add those together, I get 36, and the square root of 36 is 6. So I know this is a length 6. As I want something in the same direction, it's got to be a multiple of this. Now, you could just divide by 6 to get that unit vector, length 1, and then times by 30. Even better if you notice that 6 times 5 gives you 30. So as this is length 6, if I times it by 5, that would give me length 30. And if I was to distribute through, I would have that as my answer. But I think that answer is equally satisfactory for 3 points. Okay, let's have a look at part 3, because this one's a little bit more complicated, but also one I've seen on several papers as well. Find the value of the constant P for which OA plus P times OB is perpendicular to OC. Now, one thing about perpendicular is we know the dot product is 0, so we're certainly going to have to focus on that. I know that OC is -2, 5, and 2. So now I've got to work this part out here. So OA is 2, 3, and 6, plus P times OB, which is 0, -6, and 8. And if I distribute these, P times 0 is 0, P times -6 is -6P, and P times 8 is 8P. As I'm adding these together, I just add similar elements together. So the top row, so 2 add 0 is 2, 3 add -6P is 3 minus 6P, and 6 plus 8P is just 6 plus 8P. And I'm going to scroll up just a little bit. So I've got to show that this is perpendicular to this. So what we said earlier is that means that the dot product is 0. So in other words, 2 times -2, which is -4. This was 5, so 5 times 3 minus 6P would be 15 minus 30P. And I'm starting to run out of room here. 2 times 6 plus 2 times 8P is 12 plus 16P. And I know that the answer to this has to equal 0. So if I start combining terms here, I got 27 minus 4, which I know is -23. I think this was actually supposed to be a positive sign here. I think I've lost a sign here somewhere. 30P plus 16P is 46P. And I know the answer has to equal 0. I can bring terms to the other side. 46P equals 23. And then if I divide both sides by 46, then I get P equals 1/2. So a slight variation on the question. You are trying to use the fact that dot product is 0, but you're also showing that you understand how to solve equations at the same time as you're doing that. I think I have part of the solution here for this one, so let's just check. If you did want to work out that angle, you should have found it was 160. We did times it, see it was 5 times this angle, or you could distribute through as we talked about. And on the last question, it was 1/2, so I must have lost a sign somewhere as I was writing my answers down. And that's what I got for not leaving myself enough space. But yes, it should be 1/2. Notice you do get points for mentioning that the scalar product equals 0, so certainly worth mentioning while you're creating your answers.